Good afternoon, everybody. Yeah, so Alex Nichol from Arista Networks. I work in the software development team at Arista. So, and funnily enough, one of my focuses is EVPN. So, and this is a sponsored presentation, but I've kind of built it like the deck, kind of like obviously with a bit of perspective of what Arista sees EVPN going. But at the same time, the other bit of my work as well is I work the ITF, so that gives me insight into what other vendors are doing, what other vendors are actually proposing in terms of drafts. So I'm kind of take those two pieces together to give you insight of not only where we are with EVPN, but where is it going forward. And then the third piece I do as well is, which I think is probably the most important thing, certainly from my perspective, is I'm responsible for all the interop testing we do. Right. So I don't know if you're familiar, there's a yearly interop event that happens in Berlin by the ENTC, and funnily enough, in there is the full gamut of EVPN testing, right, across all the vendors. So why that becomes really important is it's all right talking about drafts and proposals, but a lot of that's pie in the sky, right? It's really about when you start doing the interop testing, you're really seeing what actually works, what actual paths certain vendors are taking, right, and why they're taking that certain path. Right, so the point being is that's kind of where this slide deck is coming from, not just the Arista point of view, but ITF drafts, and what we're also seeing other vendors do as well at the same time. So before I go into the details of it, I think it's probably worth kind of a bit of history of how did we get here in the first place. Right, and I'm sure you're all kind of familiar with the room in here of kind of started way back. When we talk about VPNs, we really talk about IP VPNs, right? RC 2447, and then it become a 4364. What was really cool about IP VPNs at the time and the RFCs at the time was it had cross-vendor participants, right? So what I mean was multiple vendors were actually authoring the draft. So when it became a standard, we had consistency across the vendors when we talk about the VPNs to a point, right? Because there was an agreement about the control planes, the address family, and how everything else should work. Not to bring it up, but things started diverging when we started talking about multicast. Right, whereby different vendors started getting competitive, started looking at how do I get my solution out to the market first. So we ended up with multiple multicast or MVPN solutions, right? I'm sure we're all familiar with Draft Rosen, and then eventually next generation MVPN, right? So the point being here is that we're still got a level of divergence that's creating a level of confusion in the market, right? We need to start thinking about which vendor, therefore what implementation has actually followed. And it really got worse, if you want to think about it. We get further diversions, we start looking at Ethernet services, right? So if you look at point-to-point, typical pseudo-wire, it's LDB signaled, right? But then we start looking at VPLS, things get complicated even further, right? Again, based on different vendors, LDP, let's signal it via LDP. Let's do auto-discover by BGP. No, let's signal it via BGP, right? So we ended up, again, different vendors, different implementations. And therefore, the point being is we ended up with this madness, right? Yes, we had all the services we required, right? We had point-to-point E-line, point-to-multipoint E-LAN, we had MVPN, multicast, with layer 3 VPNs, right? But we had multiple different ways of doing it. And as a customer or a consumer of it, you really had to start digging deeper into what was your implementation. Is it only working with yourselves? Does it work across vendors? Right? Again, not so much a problem with layer 3 VPNs, a lot more a problem in terms of Ethernet services. And then even in multicast, as you're probably all familiar, you get multiple implementations of multicast in terms of how you want to signal it, which forwarding plane you want to use, and such like, right? So the thing's getting very, very complicated. So the point being is there's very little, there is a level of interop, but it's really when you only really do interop when you're tuning down the knobs and you're not really doing what you want to do. So this is kind of where EVPN came about, right? It was really looking at, now that we understand the problems, right? If you start looking at it from a clean sheet of paper, we understand the requirements, can we learn from what we've done, right? So what can we build, knowing what we know now, and make it simpler? And if you're kind of familiar with how it actually came about, is actually there was two drafts running in parallel. So the first draft is all about what's the requirements. If I'm going to build a layer 2 VPN service, specifically aiming at VPLS, what do I want to improve and make it better to what we currently have, right? So that's the requirements doc. And really the requirements doc focused a lot on things like a need for a standardized way of doing multi-homing, right? Because again, if you do VPLS, not a traditional way of doing multi-homing where it'll be all active or active standby. So how can I build a protocol that's going to allow that to happen? Right? At the same time, when I do it, how do I do load balancing? How do I do fast convergence? And then how do I do PE discover, right? When I say PE discover, I'm not just talking about remote PEs, but also when I'm doing multi-homing, how do I do discovery of my PE, my peer PE as well? Right? So that's kind of the requirement draft. And running in parallel of that at the same time is actually the RFC itself, right? So we're kind of working each time the RFC was getting developed, or the draft was getting developed, going back to the requirements document, adding extra functionality into the requirements doc. Right? But I suppose the important point here is a lot of the focus initially, I'm not saying it wasn't built to be expanded, but a lot of the focus initially was about the problem with VPLS or Ethernet services. And specifically with MPLS at the time. So this is why you ended up with this the first draft, or the first RFC 7432, right? Which is you're now defining a single control plane, a BGP control plane. You're defining a new address family, and within the address family, you're defining a new set of routes. And again, looking at the problem very much from an Ethernet service perspective, those routes are what's termed as type 1s and type 4s, which are all about how I solve the multi-homing problem. How can I do all active? How can I do active standby, right? And then you've got the control plane now as well to advertise MAC addresses. So instead of the old way of doing flood and learn, you now have the ability to do MAC advertisements via the type 2 routes. You also have the potential via the type 2 routes to do MAC IP, so you can do ARP suppression, right? So a reduced amount of flooding, another requirement within the original draft. Right? And then the type 3s are all about auto-discovery of your neighbors, but it's in part of the bridge domain. Right, so that's the sort of basis of EVPN itself. And the other point here is, and this is again a bit of a pivot that happens in the future, is very much looked like as an Ethernet service, and very much looked like as a problem to be solved from an MPLS VPN perspective, right? An operator or a service provider. And really with the origins of the initial draft, you kind of went forward from there, building on that, and really there's no new at this point in time, as we go forward, there's no new routes being advertised here, there's just additional communities on the routes. But what you're now doing is extending the capabilities to do other Ethernet services. Right, so building on the multi-homing capabilities in RFC 4332, you've now got, in addition to MPLS, you now add a PBB forwarding plane. You're now adding virtual private wire, so replacing a pseudo wire now with the ability to actually signal a point-to-point circuit with no MAC learning or anything, all using a type 1 route. And then you have E-tree as well. Right? So the point here I'm making here is, up to this point, really the driver here of all the standards body was really all about Ethernet services, and Ethernet services to replace existing services that we do with MPLS. Right? And it was not a thought process that the work was done, but it was a thought process that the chunk of the work was done, and going forward, it's going to be incremental. Right? What kind of happened then is, at the same time, is we had a bit of disruption, right? So we're looking at the problem very much from an MPLS perspective, how to replace VPLS, pseudo wires. I'm not looking to replace IPVPN because I don't have a great problem there. I'm not looking to do multi-homing. So I'm really looking at the problem here from a MPLS Ethernet services problem. But at the same time, there's disruption happening in the whole data center, right? Where we're now building data centers at the point in time where there are all these spine fabrics. There's the explosion of VMs. I now need multi-tenancy inside my data center. But at the same time as I need multi-tenancy in my data center, a lot of conversation, certainly at the initial point was, well, let's just run MPLS in the data center. Okay? But then, does that really work? Do I really need MPLS in the data center? Yes, I need the VPN functionality, but I don't need MPLS, right? I don't need MPLS because I don't need traffic engineering inside the data center because I get plenty of bandwidth, right? These fabrics are 100 gig, 400 gig, some of them newer ones are even 800 gig. Right? So there's not limiting the amount of fiber, plenty of bandwidth. So I don't need the TE capabilities that MPLS might offer. And I don't need the fast reroute capabilities either, right? Because you've got ECMP in these fabrics, right? So it gives them my fast failover if required. And at the same time, what's kind of sometimes lost is a lot of these data centers, you're talking about 100, 200 leafs. So that the cost point or the boxes or the PEs, there's hundreds of them. So the idea of putting all the MPLS functionality into a top-of-the-rack switch becomes very expensive. So this is kind of where the evolution of a new forwarding plane comes in, which is where VXLAN comes into play. Right? VXLAN is just Ethernet and IP. It gives me the capability to add a label, a VNI, so I can do the multi-tenancy. So then the question is, can I make use of VXLAN with an EVPN control plane, right, to start doing the multi-tenancy that I can do in MPLS? So this kind of like really kind of disrupts things in terms of how the whole standards body and how things are then evolved, because we're now looking at separate problems. So if you look at, again, going back to what the initial problem with EVPN is, it's all about Ethernet services, right? Multi-homing, how to provide point-to-point services, point-to-multipoint services, how to do multi-homing, how to do MAC learning and such like. But when I start looking at a data center, when you talk about data center, there's not this religious idea or this thought process of it's a layer 2 service or a layer 3 service. In a data center, they're the same, right? I'm integrating both. I'm doing both a layer 2 and a layer 3 at the same time. So then the question is, how do I start adding layer 3 functionality on it? And I'm not saying this wasn't driven from an MPLS, but there was a major driver coming from instance, inside the data center itself, right? Because if you're doing virtualization, you want to do not just layer 2, because you want any server anywhere, but you want to also do layer 3 at the top of the rack. And then when you start playing a lot of these data centers as well, they're also looking at multicast, right? Because a lot of financial uptake in the data centers, so they're looking at problems for multicast as well. So this is kind of like next phase, if you want to think about, of the whole EVPN evolution, right? So you've now stepped from purely Ethernet services at this point, and a lot of focus on, and you're now moving to how do I do this and build this model to fit inside the data center, right? So this is where you start looking at, well, a couple of things, integrated routing and bridging, or IRBs it's termed. Right, so that's going to allow me to do the optimal top-of-the-rack routing. But at the same time, the other big problem, I think, and another big change here is there's also an outlook now of I'm running these VPN services, whether it be some sort of cloud telco data center. I want to also integrate with my backbone, right, which is on EVPN. So this is where the first sort of work started on gateways, right? And that's becoming a big focus at the ITF, is how do I integrate that service, that VPN service, with existing VPN services, or how to integrate it with different transport models. How to go from VXLAN to SR, or VXLAN to SRv6, right? So this is where you start seeing work on the gateways. So how to actually also scale these EVPN domains, because these are massive EVPN domains, right? So again, individual pods inside a data center could be 200 leafs. You could have 4 of these inside the same data center, right? So how do I scale them? Again, this is where the work around the gateway work comes into play. And as I say, the other big bit of work, again, very much data center focused, but we're seeing it leaking into the general MPLS use case, is multicast. Right, so, or OSM, as you might hear it termed. Right? And this is now, when we talk about OSM, we're now talking about additional routes and additional functionality on top of what the original standards were doing. Right? So this is where you might hear things like type 6, type 7, type 8 routes, right? To how to signal your IGB joins, how to signal them when you're doing multi-homing, which is where the 7 and 8 come into play. All right, so the point I'm trying to make here is that a lot of the work and a lot of the focus now in the ITF is coming out of what's happening in the data center. And it is certainly proliferating outside as well. So this is kind of, if you were familiar with the IRB, is certainly, IRB is actually, when the standard itself offers multiple different models. Again, if you look at where we are now to where a lot of vendors started, you had almost all of them supporting either one of the two, asymmetric or symmetrical. At the time, due to limitations in the chipsets, so there was this concept of riot, which is route in and out of a tunnel. Some chipsets couldn't do that. So for that reason, some vendors were then pushing centralized IRB, right? Which meant you were doing bridging at the top of the rack, or your PE to a centralized node that had the capability to do the routing of the IRB functionality. But I suppose the point being here is, over time, these have kind of now merged to a point, and this is kind of where I'm coming from the point of view of when I start doing interop testing, very much converged on one model, right, which is more common model, either even you're running an operator or you're running a data center, symmetrical IRB is a more common model. Centralized IRB has some value, right? In certain deployments, you see a lot of that sometimes used in sort of internet services when I'm providing internet service across a layer 2 circuit. Asymmetric not used so much. Almost no vendors actually doing that anymore. Just simply has its scaling challenges. On the right-hand side, it doesn't come out very well to resolution, but this is a lot of work going on. We started off with this very simple multi-homing model, and it's getting very, very complicated, right? Because as we go forward, we started off with this idea of all active or active standby. What more could you need, right? But now you have things like port active. You have different DF election models, right? You have different DF election models for multicast, right? So when I go to the ITF every quarter or whatever, the majority, if not 25, 40%, is all around multi-homing because it is becoming very complicated, right? So it becomes different challenges because there's different use cases for each time, right? And the use cases vary from whether it's inside the data center or outside the data center, right? So if you look at a data center, typically the connection points are very common to a server, dual homed, very consistent. You look at it outside the data center, your CE connectivity is going to vary, right, based on fiber runs. So this is why you need different models. Port active, you have per flow ESIs. So again, multiple and different DF election models as well, right? And then the other thing that, again, is driving from the data center is the whole idea of multicast, right? So we're not seeing a lot of customers want to move away from NVPN when they talk about what their current deployment. Why? Because they see it complicated and it works for them, and moving to what's termed as EVPN OSM, to them there's not a great amount of benefit, right? Where the benefit for most customers is going to be is the fact that they now can run triple play services. So what I mean by that is they can make use of all the multi-homing models, and they can do that multi-homing model with layer 2, layer 3, unicast, and do the same thing now with multicast. Right? So again, this goes back to your connectivity from your CE. It's multi-homed, I'm using an ESI. If I want to do multicast, then I want to use EVPN at the same time. So that's kind of the drive of that. But sadly, when we talk about EVPN OSM, it does still have the same, not the inherent problems, but the complexity you have with NVPN, right? Because EVPN OSM is the control plane, obviously, how you signal your joins and your receives. But you still have this whole plethora of different transport models, right? So you can pick your poison where you want to run English replication, PIM, RSPT, point-to-point, multi-point, MLTP, whatever, right? Or even TreeSID. So it's not fixed in one particular model, right? So the bigger question is not moving to OSM, it's more about what transport model you want to support. And then the other thing which I find really interesting is how do I actually connect my EVPN domain, right? If you're seeing this, we're seeing this customers deploying inside the data center. They're also typically deploying it in the WAN. How do they stitch the two of them together, right? And how do they scale the whole thing as well? How do they go between different transports? How do they scale and provide a hierarchy? So this is where, again, a lot of the ITF work is currently. It's all around gateways, right? Because I'm going to be migrating to EVPN. I'm also wanting to be scaling EVPN. So you have this whole different ways of deploying EVPN gateways, right? Whether it's be simply for scaling reasons, transport reasons, I'm changing transports, or I'm simply transitioning or migrating from legacy model, VPLS, to EVPN layer 2 VPN, for example, right? Or IPVPN to type 5 routes, right? So again, multi-homing, big focus at ITF. Gateway work's another big piece of the focus. And we're doing for time. I kind of try to again, obviously a bit of my outlook on things coming from Arista, but at the same time it's also bedding in on where I see the ITF going and also where I see some of this interop going as well, right? Who's adopting what? And you can see, I suppose the important point I'm trying to make is, if you look at the data center, almost all the RFCs, right, whether it be layer 2, layer 3, multi-homing, multicast is all deployed very maturely inside the data center. The only thing that's not really deployed in the data center, because there's not a big use case for it, is something like VPWS. Whereas if I took it from a WAN perspective, so now I'm talking about either SR, SRv6, or MPLS, right? You're traditionally seeing most customers want to transition their Ethernet services, so pseudo-wires or VPLS, to VPWS, EVPN VPWS, or layer 2 VPNs. Why they want to do that transition? Because they see the immediate benefit of the whole multi-homing piece. Right? I can use the same control plane. I can do a point-to-point or a point-to-multi Ethernet circuit, right? Again, solving all that complexity I had before with VPLS, LDP signal, BGP signal, the auto-discovery, all that problem goes away, right? So that's where you see a massive adoption of customers. We're looking at, if I'm looking at EVPN, they're typically looking at purely from an Ethernet perspective when they're talking about MPLS. But at the same time, we're now seeing, again, due to a lot of these customers are typically customers who are DC customers, so they're getting familiar with the standard, how it works, how now there's no delineation between layer 2 and layer 3, because you have this integrated routine bridging. They're also now, some of them are now adopting IRB as well, right? Because again, they can see a benefit. And some of the newer sort of clouds also are adopting over, again, these are for new builds, adopting over in the top of MVPN actually using OSM with MPLS, right? Layer 3, or IVPN, a little bit slower evolution, I would say. Again, because if you're just doing a layer 3 VPN solution, right, you're not using multi-homing, right? So there's not an immediate benefit of EVPN unless you like the benefits of everything else, right? You're doing triple play services I talked about before. So I think that'll take a little bit longer, right? Because again, it's typically a service is pretty stable, it works. EVPN, if it's pure layer 3, is not offering a great amount of benefit, right? So, but again, if you flip it to the data center, as you can see, pretty much all the standards that are evolved in the data center and maturely used across vendors and customers. And then just kind of wrap up a little bit, this is kind of, I don't know if you're not familiar with the NTC. So the NTC do interrupt testing every year, right? So this is multi-vendors. The vendors get them the chance to propose tests. Again, the focus of the tests are evolving ITF standards, right? So the way it works is you typically have 4 or 5 different test beds. So you would maybe have an EVPN VXLAN test bed. You would have an EVPN or SR, I should say, EVPN SR test bed. You would have an SRv6 test bed, and you might even have an MPLS SR test bed, right? Just doing transport testing. So the point being is that you've got vendors, each of these different evolving technologies. They're in different rooms. You're doing interrupt testing, but what you're all seeing at the same time is which of these drafts or which of these standards are being adopted across different vendors, which ones are actually mature to the point where I can just enable it and it just works first time. All right, because that's kind of like a lot of the challenge. It's all right talking about standards, but because the standard itself hasn't got one way of being implemented, there's multiple options. Not all vendors implement every single option. So you end up with this interrupt challenge. But what I've tried to lay out here is kind of get to where I think the whole standards body is and how I think we are in terms of maturity. So across vendors, I think when we talk about EVPN, and we talk about EVPN VXLAN, certainly have unicast services, certainly from a multi-homing perspective, that's pretty consistent across vendors. I'd be quite comfortable saying to you that I could drop any other vendor in there and we could get that to work, right, comfortably. It's the more newer standards, right? Multicast is certainly going to be a challenge, just like we had with MVPN. Now, when we talk about multicast from an EVPN perspective, again, divergence. And a lot of that divergence is not in the control plane. Divergence is really around that transport model, right? Am I going to use MLDP? Am I going to use ingress replication? How am I going to signal all that, right? So same challenges we see with MVPN, sadly do pop up with a multicast with EVPN. The other piece, which is kind of sometimes forgotten, but is very complicated, is this whole gateway piece, right? Because that becomes a very critical piece because, again, if you look at the different interrupt testing we're doing, you're doing VXLAN for the data center, you're doing MPLS SR, you might be transitioning to SRv6. So the gateway is really all about stitching that together and scaling it at the same time. There's multiple drafts to do this. Certain vendors have went in different directions. But getting it to interwork at this point in time, I wouldn't say it was fully mature, right? Because again, different vendors are looking at the problem slightly different. So they're trying to fix something that's not consistent across all the other vendors. And then the final point, which is quite a surprise and has taken up quite quickly, is V6. All right, so dual stacking. So this is another big benefit of VPN, right? You can signal obviously V4 and V6 routes. But probably more importantly, you can signal with a V4 or a V6 next hop, right? Whether that's in the data center or outside the data center, right? So certainly from a data center perspective, and even the WAN, we're seeing quite a lot of adoption of V6. Is the underlay and is the overlay, right? Obviously, there's extra work to be done, but that's actually happened a lot quicker. So a lot of these, when we do these initial testing, you'll come in, there'll be 2 vendors, then maybe after 3 years, you'll get to a point of maturity and it's across all the vendors. V6 is literally happened between two different sessions, right? 1 year testing, following year, almost all the vendors are actually doing V6 testing, right? So I'm just about on time. I don't know, is there any questions?
Thanks very much, Alex. Thank you very much to Arista as well.
Thank you.
Sponsor.